the univariate analysis of the data set. Why are we doing that? Right? This is part of the data science process. As in scientific process, there are a number of steps that we need to take. First, as you have tried last time, think about the questions and in your last assignment as well. The first step, you need to identify the questions. You need to identify the problems that you want to address, that you want to answer. After you have that questions, after you have the pain points, then you can after you convert the pain point to the problem that you want to solve, then you can collect relevant data and then perform analysis and make conclusions. These are the steps in statistics. These are the steps in scientific method, in research, and in data science as well. So the art and the science of statistics focuses on steps 2 to 4, how to properly collect, analyze, and make conclusions about data. Okay. Right. So why are this important for us for this course? This course aims to bring about the concepts of modeling and visualization to you guys. So you need to understand the concepts of how data are distributed, how are they located, how can you measure the location or the spreads from the data. And statistics plays important roles in these matters because statistics is about those concepts. And as in the first lecture that we have covered the steps in data science, you see that the entire process here also resembles scientific process, that you start with asking question, identifying the business need, and then identifying data that you want to use. And from this data, you can extract the understandings. You know whether you need to treat the data somehow, and whether you need to clean the data because there might be problems residing in the data. So understanding data is quite important, and this is part of today's lecture, that we want to create visualization in order to understand data more, and then we can do something about it. We can treat it with to correct the dirty data part. And afterward, you can then prepare data for modeling, and that preparation process require the understanding of the data. So today's lecture will allow you to let's say dig deep into the data, see the patterns, and then know how would you deal with the data set. The technique that we will use, we have already covered them last time. Right? We have already covered the functions that you might want to use in order to do some things related to this. But in this time, we will take a look at the underlying concept of those graphs, and also some of the statistical part that we have not yet to explain. I have not yet to explain about the measurements and the statistical concepts underlying those graphs. So when we talk about data, we can understand data in different levels. Starting from, we can try to understand what do we have right now, understand what they are at the moment, and that types of analysis to understand the data like that is called descriptive analytics. Back then, it was called the descriptive statistics. The same things. You may have heard that from the statistics class this semester as well. The next one is trying to understand the associations between variables, particularly the output variables or the dependent variables and input variables or independent variables. Again, these are the things that you might have heard in your statistic class in hypothesis testing, but that will be after the midterm, I guess. About t-test, f-test, ANOVA, these are the techniques that allow you to test the hypothesis to determine whether there are significantly the different groups show different distributions, and if these different groups come from the partition based on certain variables, then that would mean that the thing that you are trying to measure associate with the factor that you use to separate the data set, right? So this is about the second one, the diagnostic analysis, diagnostic analytics to determine the factor that might be the root cause of the problem that or might associate with the thing that you are interested in. Third one, uh, the third level is to understand the probability that understand to a certain extent that you can infer the probability to predict the probability of the actions or events that might occur, like predicting whether customers would leave the company, predicting whether customer would fail to pay in time or not. These are called predictive analytics. And the last one is the personalized analytics, prescriptive analytics, which aims to identify, I would say, uh, personal personal recommendations that each individuals in the data set that you want to analyze would want. Like Amazon might want to predict the types of products that you want to see when you go to the website, then you see those products. Right? YouTube might would associate your behavior when you watch video with the existing data set, and then select a set of contents to show you. And these are the analytics at the level of the prescriptive level. Right? So in this level, the system has to determine items that you might want to explore. So these are different levels. And these different levels would bring about different products, would have different difficulties in implementations, and because of the data requirements, because of the scale of analytics. And this would also associate to the value differently. The value here means the direct value that you from those products you can generate the revenue directly from those products. For example, system like recommendation system, recommendation engine, you can integrate those type of systems with a website to create a product directly and then bring about the value in a short time, means selling things. Why for these two? It doesn't mean that the descriptive and analytic, descriptive and diagnostics are inferior than prescriptive. Though remember that there are different level of usage of data. If you want the machine, if you want computers to use the results of prediction or the result of analysis, you might consider the upper two, the upper two items here, predictive analytics and prescriptive analytics, because system can then use data that are already analyzed, determined from these two models, these two types of systems, to send information, to send marketing offer, to send the offer of the products to you guys. But these two analytics would not help answering the question like what types of policy the organization should make, or whether there are problems currently facing us right now. Right? In order to understand those, in order to allow human to understand data, we need to focus on the lower tools item here. These two items focus mostly on the data set, on the distribution of the data, on the association within the data, and it allow um, the decision makers to decide the policy, to create a policy, to make a campaign, to make decision based on data. So the descriptive analytics and diagnostic analytics play important role in those parts. Okay, so and these are the thing that we focus in this course. In the I would say lectures before midterms. Yeah, in the lecture this time, because we will have just 2 slots before midterms. We will have this lecture, this class focusing on descriptive analytics, and the next class will focus on associations, to determine association, and then that's about it before the midterm. We have times only just that, because next week is again holiday, for the Makabusha holiday. But no worry, I have already assigned lots of work in this class. You still have work to do in the data camp as well. So use the holiday wisely, do the assignment, and things will be fine. Okay, so how to understand data? We can create a graphics, right? We can create graphics to help us create graph. We can use descriptive statistics, use that you will learn in your stat course, right? Like measuring mean, median, skewness, kurtosis, and other types of measurements to determine the distribution and associations between data. Right. For our course here, the next 2 lectures, what we will use are mostly graphical, but sometimes we will revert back to descriptive as well. Okay, so the key to understanding distribution is to know what distribution is. Okay, distribution, if we refer to it in terms of the frequentist point of view, right? Distributions is the frequency distribution, like how often that thing occur. Right? Distribution in this sense would be the frequency table. The graph would display the frequency of different items. Right? I can create frequency distribution of our class, right? All views based on the provinces that you are from, and then I will have the frequency distribution of students in our class. Another definition of distribution is from, I would say, Bayesian point of view. Right? The Bayesian point of view view distribution differently. So instead of viewing it just the frequency that thing occur, and then we could only measure the likelihood or the probability of thing would happen based on the frequency alone. Instead of that, probability distribution would display if we can estimate the types of distribution that we have in the data. Having probability distribution will allow us to explain the behavior based on the shape of the distribution. Probability distribution is the mathematical function. It's the mathematical function that explain how the likelihood of certain values in the data set. Right? It will explain probabilities of occurrence of events. Right? We will take a look at both frequency distribution, how to create them. Sometimes this would be called empirical distribution, because we create the distribution from data directly. Empirical mean evidence. Distribution from evidence. In other words, the frequency distribution. Okay, now the data format that we need to use in R in order to create this type of distribution should be in this way, that we need to have one row per one record. This is important. You need to have the data in the format that you want to describe distribution first. What does that mean? Each row need to be the unit of analysis that you want. Okay, if for example I have the superstore data that you play with last time. If we use the superstore data, that data set is in the transactional level. But if I want to see the distribution in terms of customer, that would be a bad idea because the unit of analysis is not at the uh, it's not at the customer level. So what I would need to do is to summarize the data set into customer level first before analyzing the distribution. You need to prepare the data using techniques that you have already learned it to transform the data set so that each row reflect um, the record unit of analysis that you want. And column indicate the measurements of that unit of analysis. It can be the amount of money. It can be the number of items that customer purchase. Some types of measurements of those unit of analysis. It need to be and each column, because of that types of measurement, would have uh, two different types of data types. It can the the column can be quantitative. It can be just values. And by having the quantitative or numerical data, you need a set of techniques to analyze distribution. If the column is categorical, string, right, but string that reflect category though, be careful. You should not analyze distribution of ID, right? ID may be strings, maybe numericals, but they are not the thing that you will analyze the likelihood of the thing that happened, the distribution of that happened. Although most of the time it is the case. Sometimes you need to group the data based on those ID first, and then you can analyze distribution of those. Like you need to each row to be the unique ID of each individuals. Okay. So in summary, the data format should look like this. You need to have table, and then each row in the table would be the unit of analysis. That means you need to know already what is the unit of analysis. You cannot blindly create a graph. That would not answer the problems, right? That would not answer the question that you want. Uh, well, if the data is already at the level that you want, then that's fine. But most of the time, it's not. Particularly when you work with the real data, the data that you have uh, would be mixed combination of multiple sources. You need to clean them first, prepare them so that these data is in the same at the same level that you want, at the level that you want, and then you can perform analysis. Then the row here would be unit analysis, and column would reflect the variable that you want to measure. I would use the term interchangeably: variable, attribute, field, feature. Almost the same thing for me here. Okay. And the variables that you want to determine, you want to analyze. In general, for the work that you do, if you are, you might have two types of variable. The first one is the outcome or dependent variable, or explanatory variable slash output slash target. For the explanatory variable, for this one, you can term it as the independent variable, or input variable, or input attributes, or input features, and or well, input. Yeah, that's just this. Right. Okay, so that means after separating them into input and output, understanding distribution of input allow you to understand what you have to associate with the output. Understanding distribution of output would allow you to know whether the job will be hard or whether it will be okay, fine. What does that mean? If, for example, the distribution of output is quite skewed, that is, you have data cluster to just some values, and so the value that you want to predict, like customer purchase a lot, high value customers only have, say, 3% or 5% of the data, then the problem will be a little bit difficult for the model to detect those patterns, right? Yeah, so understanding this allow us to understand our data more, and we want to do that. Okay, so let's start. Uh, for the distribution that we will look today, mostly they will be about the univariate distribution, because when you monitor distribution of two variables, the thing that you want to determine from those type of analysis is in terms of association between the two distribution, whether they are jointly distributed or whether they have linear relationship, certain certain um, association between the two. Uh, we want to determine those, and that would be for the next time. For this time, let's take a look at a technique that will allow us to do the job. Right. So first, let's look at frequency distribution or the empirical distribution. The frequency distribution can be displayed by using the frequency table or bar chart of the count. Okay. If you have multiple variables, then you can plot the joint frequency distribution for the categorical variable. If you have the data that is in category, if your data is numeric or quantitative, as the value like age, the amount of purchase, the sales, then to plot frequency distribution based on the value directly would be impossible, because you would have a lot of category to cover with. That means you need to group them first, right? To bin frequency distribution, frequency table. The binning means you take the range of data and then partition the range of data into bin. For each bin, then you can count the number that happens in that bin. Okay, and from bin frequency table, you go further, then you can create a plot called histogram. Right, histogram is the statistical plot that that are in a lot of BI package, a lot of statistical analysis package. It allows you to plot distribution of data. We have done that already last time using the geom histogram to plot the histogram. Okay, let's use this data set. I don't know if I gave you this one already or not. I didn't, right? Or did I? Let me check if I have that in the data set here. No. So I'm going to post the data set for you guys right now, and then you can download it while I'm get some. Okay, let me find it first. It's bankdata.csv. Okay, found it. Yeah, this one. Copy Dropbox links. Okay, I will put it in the chat here and also in our group. Somehow Facebook doesn't show up. Cannot access the group. Right. Data for lecture 4. Okay. And please download the data to your computer to use with this lecture. Okay. All right. Right. Oh, yeah. Not just you guys, me as well. Need to copy this data to the folder, the R workspace folder that I use here. Okay, done. Now I have I? Yeah, I have the data set here, the bank data. It looks like this. Let's look at it in Excel first. Here, this is what it looks like. You have the age, job, marital, education, default. This is the data from the bank. Let me explain the name a bit. This is from bank marketing, a bank marketing data set. This is the data set of customers of the bank that the bank has has made offers to, and they record the demographics data of customers out as together with the previous record. So what we have here is age, the age of customer. Job is the job occupation, customer's occupation. Marital status, education. Default means whether this customer has defaulted. This defaulted means that this customer has not paid to a level that the legal action had already been carried out, and the asset is freeze. Balance means the balance of the account. Housing, whether this customer has housing mortgage, housing loan. Loan mean whether the customer has the personal loan or not. Contact means the last contact, and day, month is the day and the month of the last contact. Duration is seconds that that this customer and the agent discuss about the issues, right? Campaigns means the number of campaigns, the number of marketing campaigns that this customer accepted previously. P day, the number of day, I think previous is the number of previous attempts, previous marketing attempt that had been made. P day is like the number of days since last contact. P outcome is the number of the outcome of last contact before this time, and Y is the outcome of this contact. So think about this as a company trying to contact customer, and Y reflect the success, accept the offer, and not accepting the offer, not accepting the deal. And the P day previous and P outcome refers to the last time. Okay, duration refers to the time it takes and that this customer discuss with agents for this phone call, for these phone calls. And the others are demographics data. Okay. We will start with reading this data uh, into the into R. So I'll start with bank data. I use the name bank data, right? Okay, bank data, then um, read.csv and the data that you want to read in. As you have seen that the data set use semicolon to separate between column. That means the step here should be semicolon, right? Then you can run it and you get the bank data in. You can try to view it first to see that they are properly imported. Can also check the type of distribution. str allow you to know the structure of the data, and you can see that, and then you can look at the structure and see whether the data type is correct or incorrect. Age here is integer, job is correct, okay. Balance is number, housing, loan, contact days, okay. Seems to be properly imported. The next things that we will do is to start asking the question. So what should be the question that we should ask first when we already imported the data? The question should be, not this one though, not the one that I show you here. The question should be, what should be the proper level? What should be the unit of analysis that you need to prepare the data for the distribution analysis? For this one, since we already have the data at customer level, so it should be okay to start analyzing it now. So let's take a look at the way that we can perform the analysis here. You may ask, what what are the job distributions or the job proportion of our customers? Knowing this will allow us to know the types of jobs that the customer have, and then we will know that our portfolios contain people from which backgrounds. How to do that? Think. How do we determine the job distribution? We need to plot, right? We need to plot the distribution of, you can answer that through the chat. How do we know the job distribution? Well, but the answer is already in the next one. So let's move on. Then you can answer that with your own data set. Okay. In the lab. Okay, so in order to know the distribution of the job, you need to display the frequency table, right? Frequency table can be displayed in this way, that you can group the data based on the thing that you want to display, and then summarize it with the summarized function. Okay. So I'm going to import the tidy words and then using the bank data and group by job and then summarize it based on the number of instance. You can also do that easily in SQL in your database, because if you are working with database. But since we are working with a flat file or with a file here, we will carry on with the function that we have here. I'm going to import the tidy words. Then from the bank data, pipe, group by job, because we want to determine distribution of job. Then summarize, n equal n. The n function here refers to the number of row. Then we will have this one. If you want to make it nicer, then you can do something like arrange ESC n. Right, then it will be arranged based on the proportion. So we can see here that blue colors has the largest portion, then management, technician, admin, and downward here. So in the analysis, you might want to you might want to uh, group you may want to group students if because unknown here contains only like 300 of them. So if you want to create a model later on in after the midterm, then this group would be quite scarce, and also for the students as well. You might consider grouping them together, for example, as authors. Okay, and this also allow you to see the distribution of whether there are like incorrect labels. So many times that in the real data set, you encounter the labels or the fields in the database that are incorrect. And by looking at distribution table, allow you to see those fields, to see those categories. Then you can decide to group them or correct them to be having the same names by using the function to replace the value here, and that allow you to group them together. Okay, this is the frequency table. From this frequency table, you can determine the large group, right? These are the large proportion group and the smaller proportion group. And from this one, you can see that they are quite skewed, not uniformly distributed. Right? That means the blue collar, technician, management are the main proportion, admin as well, and service are the main proportions. And number 6 to number 12, these 7 groups are forming the smaller proportions. Okay, so that is for the first question. Then how about this one? How about the social status? How many customers are married and graduate with tertiary levels? The other question might be, we want to know the customer segments that we have regarded to the marital status and educational profile. And that can be done by jointly analyzing the distribution of these two variables using group by with two uh, with two variables as groups and then count the number. So from this one, I use the bank data and then use group by and then group by marital status, marital, and education. The resulting of this group would be the table of the same data set with group attributes. And then we can summarize it. The result of this one will look like this. Now we have the joint distribution of the marital, education, and the count, the number of instances that this happened. But you can see that it is hard to understand in this format because these are in the data are in the long format. It's not good for human to analyze two variables in the long format together. So I'm going to pivot it up, pivot to wider, or using spread like in the lecture, spread and using marital and n to spread it out. But well, it's the same anyway. I'm going to use pivot. Pivot wider. Delete data ID column. Oh, sorry, this one. Data ID columns, name from, and value from. Data is already carried over from the pipe operation. Then let's specify ID column. ID column. What should we have as the row? Let's say marital. And then the name of the column would be from education. and value would be used from n. Then we can run this and get the results that it is easier to understand for human. Because from this one, we can see that for the divorce, the distribution have a secondary as the highest, then tertiary. For merit, you got this is like 14,000, 7,000, and 1,000 here, and 5,000 here. So if we were to compare proportion, this one 2,800, 1,400, about half, right? About half. And for this one, this is 7. So this 7 should be about 1/4 of the secondary. Now let's take a look at for merit, and this is for divorce. For merit, this is about 14,000, 7,000. So yeah, it's about 0.5, the same distribution. But for primary, you got this at higher level, right? Because if you compare, is not one fourth, is about 1/3, actually 1 to the 2 point something, I suppose. Because and this allow you to know that okay, there are certain might be association between the two if you plot them together like this. Right. So this is a joint frequency distribution. Or another name for this is the contingency table. We will take a look at the way that we can analyze the data from these types of table next time to determine the association between variables. Next, instead of looking at the number, we can look at the graph. The graph that allow us to determine frequency from the category data is the bar chart. By using the geom bars, it would count because geom bars use stat count. This would count the number of occurrence or number of row of each value. Okay, so by assigning x equal job in the aesthetic mapping and use geom bar, it would count the number of occurrence of the value here. Yeah, so here I'm going to use bank data, and then maybe using this directly, ggplot, and then bank data. Then, oh no, plus geom bar, right? But I need to specify the aesthetic mapping, AES x equal job. Then I will get this geom bar, but you can see that it's hard to see here. So I can also use the coordinate flip to flip the name up to y-axis so that I can read the name easier. And then maybe arrange it a bit. Arrange DSC of job. No, of count. But we don't have the variable here. I don't know if this would work. Shouldn't. Because if we just arrange here, then we would not have variables. Maybe that would work with the summarization of n, right? But for this one, just try find it out. I think it's just a little bit of trick to refers to the y-axis that is now at the x-axis. Then you can arrange the data, sort the data based on the count. Right. In any case, this is the way that you can plot the distribution, the frequency distribution of using geom bar. Okay, that is for the categorical data. Now, if your data is numerical, if your data is the number, how do we plot the graph? You can create the binned frequency table. Okay, for the binned frequency table, you can use the function called histogram to help, or you can use the histogram in in ggplot2 to help as well. So creating binary frequency table can be done manually by using if else, or it can be done this way, that you can just using hist, and then from this edge, then you can obtain the count and the breaks. And then for the count and the breaks, this would give you the breaks values. So the first one is at 20, and the second one at 30, and then the counts of the number of instances that are in that region. All right. So for this one, we need to define the BRK first. For this one, I use the 0, 20, 40, 60, 80, 100, I guess, right? Yeah. No, because I use 30, 40, 50, 60, 100. 30. It's a custom breaks, and 50, 1600, whatever. Okay, this is a BRK. Yeah, let's use our notation. Okay, now I have the BRK, then I can use the histogram. Actually, if you just use the histogram like this one and say that you want to partition the age data, bank data, dollar sign age, if you plot a histogram that use the default values to plot the default value in the histogram function to plot this out. And you can see that this is a histogram of age, but you can also adjust the break of the division of the age data by specify your own break here, and then say that doesn't have to plot. And then this histogram would result in the object. This object contains the breaks, the counts, density evaluation, if you want to have the probability values, and the others accompanying value here. So I will use H to receive the data object here. And then to plot frequency table, I will just create a data frame. That using, we know that breaks should be the H dollar sign, and then using breaks. However, if you look at the breaks, there are 1, 2, 3, 4, 5, 6, 7 elements, while the count here contains only 6, density here contains only 6, because the when it counts here, it would count the value 97 refer to the value between 0 and 20. 6,933 here refers to the value between 20 and 30. And then this value refer to the values, the count between 30 and 40. Okay. So I'm going to use -1 here to remove the first index out. And then for the values, we use H dollar sign count. And that results in this breaks and value. All right, so we have the frequency table in this way. Now, how does this work? If you look at hist in the help, it will tell you that this is the function to compute histogram. And this is the break, can give vector of breakpoints. Here. It will, for the default, it will use right equal true. That means histogram cells are intervals that form in this manner, A and B. This parenthesis refers to exclusion. The A would be excluded from this interval, but B would be included. So the high value would be included. What does that mean? It means that suppose that the value hit the boundaries, which cells, which bin it should belong to. Okay, so this is for if the right is equal to, if the right equal false, then the interval would be formed differently. It would be in this way instead. let's try creating our own, play it a bit, but I need to have at least like 10 points or 15 point of data to work with. So let's use ran unif, but it would generate that, right? Not remember the function though. Let me look at the function. No, my, let's see. When you write both language, then it's quite confusing. Just want a function to generate, or maybe I can just divide sample int. Right. So let's use this value. I'm going to change share content and whiteboard. Okay. Then what I need is the data first. Here the data that we have. Let me adjust this a bit. For the data, we have 5. Let me sort it out first. 1 and 4, 2. Never mind. 1, 2, 3, 4, 5, 7, 8, 10, 11, 12, 13, 15, 20, 25. Say if we have the data that looks like this, and we want to create a bin of 4, right? Bin of 4 in this way, A and B, inclusion to the right. Right now we will create a bin of 4, say n equal 4. So how do we do that? We need to first determine the number of the step size to be used. How many samples do we have? And the size of the range of data. We have the range of data equals, so this is the maximum value and the minimum value, right? Then in order to get the number of steps that we need to take, how do we do that? You can answer it through the chat. How do we determine the step size? Where's the chat? Here, the chat. How do we determine the step size for this one? Can you make certain guess on what should be done here? Because we have the maximum and minimum, right? We have the maximum and minimum values, and we want to have 4 bin. So the steps, we need to divide the range of data into 4 bin. That means the size of bin should equal to the max minus min divided by the number of interval, right? And then we will have the size of the interval. And that is 25. 25 minus 1 divided by 4. So that would be 24 divided by 4. And that is 6. Okay. Then we can determine the range of the bin for each one. So we have 4 bin. Bin number 1, bin number 2, bin number 3, and bin number 4. Let's put in the range of data, the range of values that this bin should cover. So the first bin should cover the data starting from the minimum value, right? Starting from minimum value to the maximum. Now, as you have seen that because uh, we use the lowest value as the floor. If we were to write it like this, 1, and then 1 plus 6 is 7, like this one, then it would mean that we are excluding 1 out, right? But no, because usually the first one would be included. So say including the lowest value. This would be that would be the uh, the leftmost point that need to be included in this way. For the second one, here would be 7 and 7 plus 6, which is 13. And then this one would be 13 plus 6, 19. And then 19 plus 6, which give you 25. Okay, so this is the way that you can calculate the bin, right? So you can see that here is the plus size plus bin size. And then you get the value of the upper edge. Then let's put the element, the members to the groups. The value between 1 to 7 include 1, 2, 3, 4, 5, 7. The value between 7 to 13 include not including 7 though, because you can see from this one, 8, 10, 11, 13, 13. The value between 13 to 19 is 15, and then 20 and 25. Okay, and that means if we count this to count the number of instances in this one, we would have this equal 6. This one would equal 5, and 1, and 2. Okay. Now, if for this one, if I then use the histogram, create a histogram, then I will have the value between, say, 1 and 25, and then for each of this would be 7, 13, 19. 7, 13, and 19. And then the histogram would look like this. You get the value of 6 here, 5 here, and 1 and 2. Yeah, this would be the resulting histogram of this data. All right. This is the way that you can create a histogram by uh, binning the data into range. For this one, I use the number of bins that I want, let's say 4 bins, and then the data should be divided in this way. But the breaks or the breaks on the bin here, the breaks on the bin here can be, I would say, this value can be manually specified if you want to have custom breaks, custom level of breaks, and that can be specified to the histogram. But otherwise, when you specify it like the number of bins, the number of bins will be used to calculate the size of bin. And then the size of bin will be added to each of the level, each of the lower values. And then you get the upper value and then keep doing that until it reach the highest value, the range. Okay, any question about this first? Because this will be the core of today's lecture, that you understand the concept of histogram, because the categorical distribution is easy, right? Let me capture it. It will be in the video, so don't worry about that. There shouldn't be any problem. I already increased the capacity of of my computer. Okay, let me capture it first. How do I do that? Capture video, annotate, yeah, annotate and save. Yes, already capture. Okay, then I'm going to switch back to the slide. Okay, so this is a way that you can that this algorithm calculate the bin and count the number out. Okay, the plot that I showed you earlier is called histogram. Histogram is the graphical distribution of data. It provides the information about the density of data. It shows you that these values are likely occur. So how to construct histogram? You need to bin the range of values and then count how many instances fall into the bins. Usually bin would be consecutive, non-overlapping, based on the way that we calculate data. And bin would be adjacent to one another, and they are usually equal size for that. So this is the way that you can plot histogram beautifully using R, using geom histogram. And then you can map the value that you want to plot into x-axis and use geom histogram. Geom histogram would bin the data using the stat bin to bin the data and then count the number of instances fall into those bins. So from the bank data, I use the ggplot and then say as static of x equal h. If we were to plot just this, we would have h and at the x-axis. Then we add the geom histogram. And this results in just histogram, the blank histogram. And then to clearly see the boundaries, and I will use color equal black or white. Then we will get the histogram out. Okay, you can see that the stat bin use bins equal 30 as default value. From this histogram, how do you interpret it? From the histogram, you see that the value are having high counts at about the values of what is this? 25 to 50. So this should be 37.5. The value is high at the value level of around 30 to 40, about that, 30 to 40s. And then it then gradually going down. And then you have a little bit of tail here, indicating that these are elderly that are also purchased, but the number of instances, number of accounts are very low. Now let's look at the effects of number of when you increase the number of bins in this histogram. And that can be controlled by specifying the parameters bins. When you're specifying the parameter bins, it override the default 30 bins. So for this one, I'm going to change the bins. You can specify bin width as well, or just bin. To other values, say 10. For 10, you can see just the general sense of distribution. Like when you're zooming out and then look at the picture, you see only the outline of the picture. So having low histogram, low number of bin in histograms allow you to see a general distribution, but it failed to show you the detailed distribution. That this one might have like might not be like this one. So say if we increase it to 30, you have the value that looks like this. How about 31? How about 32? You may observe some strange phenomenon here, that when you use 10, right, you can see that each bar has low going up and then going down quite smooth, right? But when you increase this to say 20, it still looks fine. But when you increase it further to 30, so for this one, you may conclude that there are one populations that are clustered about this region, and there are certain skewness to the right because it kind of gradually reduce when we increase it further to 30. So now we see that there are certain low values, and if you conclude that these are low values and these are high values, then you are falling into these traps of numbers, because because of what? Because we have the age values as integer. Integer can belong to certain bin. They are not quite continuous. They are quite discrete. So when the number of bins and the range of value are not adding up equally, there are possibilities that some of the values may be fall into certain bin, but not in their own bin. This would happen when saying something like you are just like when you are trying to divide the even number with the odd number. That would be the remainder. So this phenomenon would happen when you increase the number of bins further. And you can see that some of the values are high, but these are not really the high value, but these are the artifacts of increasing the number of bin and resulting in like some of the bin combined together. Say increase it further to 40. There are no high value here. How about 45? Again, these are artifacts, right? Artifacts means the drawbacks of binning, right? So understand this as well, because you should not make conclusion of this value. These are the side effects of integer value. Bin is equal 50. Again, it's not like you have high value and you have low value, high count and low count. Some of the bin are high. No, it's not that. Right? Not like our customer would have like birthday 2 years apart. Like there are like 2 years to have high birth and low birth. It's not like that. It's because these are the artifacts of binning. You need to be careful about that. Now let's increase to 60. Again, you can still see that. 70 bin to 80 bins. Now there are something else. Let's say 71. Then I will increase it further to 75, 76, And now you have only just one remainder, 77. What am I doing? 78. No peaks. How come? Right? No peak. No outlier. No one values that are like spiking. What happens? 78. Look at this. Max of bank data and age. Oh no, let's use summary. The high value is 92, low value is 18, 95, 95 minus 18 equals 77. And then when you use 78, 77 still give you one spike. When you use around 78, which equal the possible number in the data set. So this is basically the plot of all possible number in the data set. And that's why uh, there's no no peak there, not peak, no spiking there. But if we increase the value further to 80, now you have the number of bin more than the number of values. And again, this will create an artifact that there are certain range that you cannot count the value because when you increase it like this, there will be some region that there will be no value in that region because now the region is lower than 1. So when you increase it like this, and then you see this value, say if it's 100, you cannot conclude something like there are some age group that are not there. There might be so in the real data set, but it might also be true that your bin is too high. So this is like the values you need to adjust uh, and determine what should be the appropriate value by experimenting with it. And see whether the value that you have are the artifacts or whether these are the real distribution. Right? So for something like this is like when you zoom in into a picture and it's starting to fall apart. Or with your T-shirt, you stretch it uh, to to Y, and then the screen on your T-shirt would be breaking. Right? So something like that is the same thing that we see here. Okay, this is the effect of histogram. Now, how about the sample? If we have, for this data set, we have about 45,000 data points. If we take only 4,500, what would happen? Let's reduce this first to say 20 bins. How do we reduce the size of data set? We can use ggplot. We can use dplyr to help us. Sample fract, and then use only 10%. Carry it over to ggplot. This is a 10% plot. You can see that that isn't much different. This is called sampling. In sampling, you can take just a sample of data out of population and then assessing the distribution of the data from the small population, from the small sample size to infer to the actual distribution that it should look like this. Right? In your stats class, you learn about this, about sampling process. Uh, and it is quite useful, especially when you need to collect the data from your customer, from human, because it is quite difficult to get the data from everyone, except if you measure it from the business process. But if you want to have something like a questionnaire to be conducted, then 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 samples is one of the way to do. Okay, let's go further then. Right, so from the data, you can see the issues that you can see some issue like here, this is the majority of the data set. It cluster at the street level, but it is also possible that you would not see anything here. The reasons that there are quite a long tail in this distribution is because there might be some outlier here, that small level here. So these are the outlier that if you include it into histogram, it would kind of stretch the range in such a way that you cannot see the data that you want. So how do we deal with those? You might want to replace this value with the value about here, and that will resolve the problems. Or you might want to remove the data out, the data that have value more than certain value here, just remove them out and then count the data that you have. Okay, these are outliers. Outliers occur because in the real process, there might be some individuals that are different from the main groups, right? Those outliers are like uh, the Stanford and Oxford dropout. Right? Like you may have heard a lot that, see, these persons are successful even though they are not taking or Bill Gates, for example, even though they are not really graduate. But the real reason is that these individuals are already excellent. They already have their knowledge more than they need to study. That's why they don't need to have a formal education. They can just study by themselves. That's all right. Right? So these are outliers. Outliers are people who are not people, individuals that have values so different from the main groups, the mainstreams. Sometimes these should be excluded if you want to make conclusion about general phenomenon. They should be, otherwise this would seriously say make your measurements wrong. What are the effects of outliers? If you measure the mean of data for this one, uh, the mean would be best if you measure the data that have symmetric distribution. Let's take a break. Then we will come back for the remaining of the slide here. Let's take a 10 minutes break. I will come back on 10 sharp. All right. Okay. Let's continue. Before the break, we have seen the effect that you might observe from histogram, and these are the outliers. Outliers are observations that are quite different from the main groups. Because when we measure data, when we try to summarize the values from the data, we have to summarize them according to certain rules. One of which is to use the average value, to use the mean values. The mean value is a good way to summarize the data based on the central tendency of its value. But the mean value here is suitable if the data are bell-shaped, like symmetric. If the data are not symmetric, then there will be problems like the right-hand side here. If the data has like 1 point going to 10, then you can see that the mean value will be affected by the outlier, the value that goes into that are not in the main group. But you can see that the main group is still have the value cluster around 2.5 and 3. So instead of using mean, if the data contain outlier, you might prefer to use median instead, because median is suitable for distribution of that have skewness and data with outlier. Because in median, you are usually arrange the data into sequence and then select the middle values. This middle value would not change even though the highest value change. So median would indicate the value quite robustly at the middle point. Okay, so these are the two measurements that you can use to measure the central tendency. In your high school, you may learn another one called mode, right? Mode refers to the highest occurrence of the instance, but that is not good here, especially if we talk about numerical scale value. Why is that? Numerical scale value can have the value that in decimal level in the like 2.5 or 0.01. Having mode, it will be difficult to determine the actual value that you should count. So mode would be like you trying to create histogram. So just use histogram, then determine the highest peak would be fine. But you can see that the effect of in the last few slides, when we see the effect of histogram, when you increase the number of bin, the highest value would change based on the resolution of the bins. So So mode should not be used here when you determine the distributions. So how to deal with outliers? One way, in order to, if you don't want to exclude the data out, one way to deal with outliers is to use the plot that is robust against the outliers. And that one of the plots is the plot that relies on the location of data instead of the average of data. Such a plot, one of such a plots is the box plot. And the measurements that accompanying with box plots are the quartiles and IQR. Quartiles refers to the points that when you sort the data from low value to high value, and then you pick the data at the point of 25%, that is, you have 25% data lower than this value. And at Q2 is actually the median. Q3 is the the point that you have 25% of data more than this value and 75 less than this value. Think about this as percentile. This is like the 25th percentiles, the 50th percentiles, and the 75th percentiles at the Q1, Q2, and Q3 respectively. We refer to the range between Q1 and Q3 as the IQR. This stands for interquartile range, the range between quartile. In the quartile range. In the quartile range come from Q3 minus Q1. And this is quite important, especially when in the box plot that it need to calculate the range to know that the points beyond this range should be treated as outliers. Okay. The measurement here associate with the percentiles. Usually we refer to the nth percentile, like 50th percentile, 75th percentile, as a value that you have the n% fall below that value. So for Q1 is 25th percentile, median 50th percentile, 50th percentile. Q3 is 75th percentile. And the plot that allow you to display these measurements, all of these measurements together, is the box plot. Box plot, as the name suggested, would plot the box. And then you would have these. These are referred to as whiskers. Right? The whiskers that go up and down. The box would start from Q1. Low value of the box is Q1. High value of the box is Q3. That means the size or the length of the box is IQR. And usually the box plot would have the line in the middle, and this is the median values. Okay. IQR, the range here between Q1 and Q3, refers to the middle 50% of data. So by looking at the box plot, you know that where the middle 50% of data located. And the whisker here can be specified to display two things, but the popular one would be the latter, the outlier boundaries. These are calculated by calculating the upper and lower values. Lower values would take the value of Q1 and then minus 1.5 IQR. You have IQR range here, just minus it from the Q1. Then you would have the lower bound. Sometimes you will see that these two have a different range. This is lower one, but it would take the minimum value. If the lower bound is lower than the minimum points, then it would take the minimum points. Again, for the higher one as well, if this would be the Q3 plus 1.5 IQR. Right? So you take the IQR and then take the Q3 and add it up with 1.5 IQR, and then you get the higher value. Any values more than this point would be treated as outliers. Right? So we will look at Python function, not Python, sorry, our function to plot the box plot first. Then we will look at the way that we can calculate and plot the box plot by hand to make you understand about how does this come by. So in R, you can plot box plot by using geom box plot. Geom box plot would use y-axis to plot the box plot, and the x-axis will be used to divide the data into groups. And for this one, you can see the whisker up here and the points. These points refer to the data points that is beyond 1.5 IQR, right? Okay, so it shows us that there are points that are beyond the whisker, beyond 1.5 IQR. And sometimes you will see the asymmetry in the whisker, that this one is shorter and this one is longer. If they are both at with 1.5 IQR, how do they differ in this manner? The reason is that the length of the whisker here comes from 1.5 IQR as about the Q1 minus 1.5 IQR as minimum boundaries. But because the minimum value is higher than that, you take the minimum value instead. For this one, because 1.5 IQR may be having certain values, and there are points beyond that, that's the reason that you have this out. So let's plot it using the function first, then we can do it by hand, just like histogram. Working as the data scientist, even though there are functions that would help you a lot in different manners, I would still suggest that you need to understand the detail of how does this, what are the say the origin of each of this plot, because in the long run it will be benefiting you a lot, because you can even create your own algorithm if you want. So this is the box plot, right? Now let's try to create a box plot by our own using the data that we already have in the whiteboard. Going to switch to the whiteboard. Share from this screen. Share content and whiteboard. All right. Oops, it already delete my last one. Never mind. I got the screen capture here. So here is the data that I have. Data. One, 2, 3, 4, 5, 7, 8, 10, 11, 13, 13, 15, 20, 25. In order to create a box plot and determine the quartile, percentile, you need to first overlay, sort the data in this manner. So how many points do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 14 points. 14 points. 14 points, right? So in order to get the middle would be 7 and 8. 7 and 8, 10 and 11. This is the middle. That means we would have Q2 equal 10 plus 11 divided by 2. This is 10.5. Oh, why do you see that? Oh, no. Yeah, I just opened the wrong one. Thought it's this one. Okay. And that is for the Q2. How about Q1? Q1 is 25%. That means from from the whole points, I should go to the 25th. So 7 is 50%. Then it should be about 3.5. So it should be about here and here. Oh, no, wrong one, right? 1, 2, 3, 4, 5, 6, 7. And then another 7. No, I think I made a mistake here. Let correct it first. Oh, okay. It's all right. Okay. Is yeah, it should be between these two, not that one. Right, the Q2 should be 8 plus 10 divided by 2. This is 9. So 7 and 9. 7, 8. Okay. Then the next one would be at the 25%. Is this 2? The Q1 would equal 3 plus 4 divided by 2. This is 3.5. And Q3 would be 13 plus 15 divided by 2. This is 14. Okay, so the IQR is IQR equal Q3 minus Q1. 14 minus 3.5. This equals 11.5. No, 11. 10.5. Okay. Now, if we plot the box plot here, we can see that Q1 is 3.5. Q2 is 9. Q3 is 14. Right? So the box would look like this. And the IQR and the whisker, because the whisker is from the upper bound. Upper for the whisker is Q3 plus 1.5. I don't have enough space here. Say, put it this way. Upper equal Q3 plus 1.5 IQR. And that is 14 plus 1.5 and times 10.5. And that would be 10.5 plus 5.25 be 14 plus should be 10 and 5.25, 10.5 and 5.25, 15.75. So the upper bound would be at the 29.75. And the lower bound equals Q1 minus 1.5 IQR. And this equals Q1 is 3.5 minus 1.5 and 10.5. And this is 3.5 minus 15.5. We have, no, it's not 15.5, it's 15.75. We would have the minus value, minus of 12.25. That makes the lowest value to be 1. You may wonder why is that? Because we have this as the lowest value. So whisker would go down to just 1 here, no outlier at the lower end. And if it's extend to 29.75, this value, then this value, then it would extend beyond the maximum value here. And that make 25 as the highest point. Now, suppose that we have something that is different, that like we don't have 25 here, but we have the value of 35 here, right? 35 here would be displayed as, then what would happen? What happened would be the whisker that we have here would not be at 25. It would be lower to only 20. And then the point at 35 would be displayed above here as outlier. Okay, so this is the way that a lot of box plot algorithm create box plot by calculating Q1 to Q2 and Q3 plot box plot, and then calculate whiskers by adding and subtracting 1.5 of IQR out of Q1 and Q3, adding, right, Q3 and Q1 respectively. Adding to Q3, subtracting from Q1 to get the upper bound and lower bound. And if the points are in between the whisker, then it would take the point in the whisker, in the range. If the point is beyond that, then it would take the point that is the level that is within the level, right, within the one that we have here. Okay, so this is the way that it works, and you can see that this is not the same. It is quite different from the histogram, but it allows you to again determine the distributions similar to histogram. Right? Histogram will show you the cluster of data, will show you outliers. But because histogram will have problems when there is like outliers really far away, box plot would help you in that regard. Okay, let us go back to the slide. Okay, and here you can use the fill to highlight or to show it beautifully. R also has a function that allows you to calculate the Q1 and Q3 from the dataset that you have. Like this one, I use the quantize to calculate the values at the 25th percentile, 75th percentile. So this is basically doing the thing that I just did, rearrange data into from low value to high value, calculating the values at 25th percentile, at 75th percentile, at the median, and at the mean to compare to one another. When you plot either histogram, when you plot histogram, you might want to look at the shape of the distribution, whether the shape is symmetric like this one, or whether there are certain skewness to the right or skewness to the left. Like skewness to the right means that the data are clustered on the left, and then you have just a few or lower proportion at the right value. Think about the skewness to the right as hard exam. In the hard or difficult exam, mostly you will score at low point. Only few would have high points. And this one is easy exam. In the easy exam, most of people would have high points. Just a few that would have low values here. So this is often occur in nature because like if we think about it, if we think about customers spending money, only few would spending a lot of money, but most people would spend at a certain level. Now, this graph, just think about like the campaign from government. that asks with those who participate can spend up to certain quota. Then you see this distribution a lot because people would try to spend as much as they can up until the quota. Only few that would spend a lot less. But there are also other possible shape that you might observe, like you might observe the bimodal or multimodal. Modal refers to something like the mode in the data or number of populations in the data. These are bimodal. You have two peak here. It occurs when you have two population. In this case, if you measure mean, the average value here, it will be wrong. Median is also wrong because you have two peaks. This means that there are two populations. You cannot just measure the average value and say that this distribution has this value to represent the whole population, because it would be wrong, right? Because the value here has low frequency than the value at these two. This can be occur if your data contains multiple populations within that dataset. Reverse J-shape might occur if your data distributed in having low values a lot more than high value. Uniform is hardly observable in nature, right? But it can be generated. Uniform means that you have the likelihood of all instances are the same. Just try to study the distribution of the lottery. Then you see that they are not uniform. Some numbers occur more than the others. Okay, data has may have different skewness. You can determine skewness by looking at the histogram, or you can look at the measurement like mean, median. Just remove mode out, right? If mean is more than median, then it might refers to the situation that you have rightward skew or positive skew. If mean is less than median, then it might mean that the skewness pull mean down, and then that makes means less than median. So just see the disparity between mean and median, and then you can determine what types of shapes that your histogram might look like. Or you can just take a look at the histogram. That would help as well. Okay, so those are the way that you can plot distribution from the data. In your statistics class, you will learn a lot more distributions. And when you see the shape and then you can hypothesize that your data has certain distribution, it would allow you to use the function that represent those distribution to do other things. Like you can generate the data set, generate more data set from your data. If you know that it should have this distribution, then you can use techniques that belonging to those class of distributions to analyze your data. What are the distributions that at least at this point you should see and know them? First one is the normal distribution. Normal distribution is useful because of the central limit theorem. That is, if you sample the data, the measurements a lot, and you do that a lot of time, the measurements tend to have normal tend to converge to certain values, and then you can use the confidence interval to measure the likelihood that the center points would be located at those regions. You will learn that a lot more in your statistics class. Though in my class here, we are not really delve into those. Um, so normal distribution look like the reverse bell shape. And the equation that govern this reverse bell shapes is the exponential. If you look at the equation here, you can see that this is exponential with minus and square. Means that if you take the highest point would be when x equal mu, because when x equal mu, you have value in the exponent equal 0, and that would have the highest point equal 1. But if these are deviate from one another, then this minus exponential would take in effects, and it would gradually decay. Sigma refers to the standard deviation, which will scale the data on both in above and down here. So the normal distribution normal distribution would reflect many of the data in the real world if they have like symmetry in the bell shape. In the central limit theorem that you learn in your statistics class, it refers to that when you sampling the data independently a number of times, the middle value would converge to a certain values, and then you can determine the likelihood of that region from the concept of the confidence interval, and that can be used in prediction later on in our class here. All right, so mean value would affect the location of the peak, the standard deviation, or the if you square it, it would be variance, would affect the width of the data set. Okay, this is normal distribution. The next one is the one that you often encounter, is the normal distribution that has certain skewness. This is called the log normal distribution. A log normal distribution occur because like there are certain skewness. There are some of the instances that have high value than the other. You might encounter this in nature a lot. And knowing that this distribute in the log normal scales would allow us to maybe correct the data if you want to use linear regression to make prediction. Linear regression has certain assumptions that the data has to distribute in normal distribution manner. If we observe that they are log normal, then it is possible to convert it using exponential to convert the data back to the linear domain before analysis. Okay, so in terms of distribution, the log normal also have the the middle value controlling by the value here in the log fashion though. So it would be log of x instead of just x. So if you plot this graph and you take a log at x-axis and then plot it again, then you see the histogram distribution here in the normal distribution manner. So this gives you a clue that if you want to know that the process it should be log normal or not, you can plot histogram of the log scale. If the histogram of the log scale gives you normal distribution, then yeah, you know that the data is log normal distributed. And there is the technique like log regression that can model the data in this manner. So analyzing the distribution of data also gives you ideas on what types of model that you can use later on. Now let's take a look at the difference, the distribution that often happens in real life, but we hardly notice them. Right? This is called the binomial distribution. Is one of the discrete distribution. Binomial distribution model the distribution of the positive occurrence given the fixed total number of trial. Like suppose that we have in like our class here, if I count the number of students that coming into each session, then I would get the binomial distribution with the n here equal the total number of students that can show up. And the number of you guys really showing up, like this one, 50 of you guys, would be the number of occurrence, that number of samples that generated from binomial distribution. Okay, or if you think about the assignments that you need to submit for each one, some of you may have not submit, but the total number of you guys will be like 56. So that'll be n, right? So and that is, and the probability of that happen would be according to this equation. The p and k, n is equal to the total number, k is the number of success, number of sorry, in reverse. K is the number of trials, n is number of success. This is n choose k, right? N choose k. I think this is reverse. Yeah. I think this is wrong. This should be n Bernoulli trial and k success. Yeah. Because of k success, we have this is p to the k, and this is 1 minus p to the n minus k. Okay. So the distribution will show you the probability of number of positive occurrence would occur. Like if for 12 times that I have the lecture here, I collect the data, then I might see that, okay, mostly you guys show up in 51, 52, or so 46. Then if I create a histogram of the number of students, I would get a histogram that looks like this one. And that is the Bernoulli process, the Bernoulli trials for each of the class here. And then number of them would create the binomial distribution if you count the number of success. In statistics, you will learn this like when you're drawing the balls, red ball from the box, how in 10 times, how many times you get 5 red balls, for example. And this is binomial distribution. Okay, and next one is the distribution that you use to model count number, like when you have the fixed interval. This is called the Poisson distribution. Like if I were to count the number of car passing in front of the university at 1 hour, that would be Poisson distribution because I fix the time length and then count the number. Or if say that I try to count the number of students that come to the class within the first 10 minutes, that would be Poisson distribution as well. Poisson distribution is used to express the number of count, the number of instances occurring at the fixed amount of time, right? It has the parameters lambda, which denote the lambda here, denote the number of event that will occur in that fixed amount of time, the mean of the number of that event. Okay. It is in reverse to this distribution. This is exponential distribution. Exponential distribution measure the time it takes for two events to occur consecutive to one another. Like for this one, you count the number of instances, the number of occurrence of the event within say 1 hour, 1 minute. For this one, you are actually measuring the amount of time between two intervals from the Poisson process. So they are in reverse to one another. Lambda here indicate the time that it takes, the time constant, that this would fall to a certain low value, the constant value. Right, so these are example of distribution, though you will learn more about this distribution in your statistics class. And in different work, in different models, there might be assumptions about this distribution. Mostly that we will see is the assumption about normal distribution, assumptions about binomial distribution that the data might have. You will work on this more after the midterm because I will have one lecture on simulating data from the distribution. Then we will take this distribution and try to generate the data of this distribution out to do the Monte Carlo simulation. Okay, that would be after the midterm exam. Don't forget to correct this though. Again, yeah, I already done that. This should be N, this should be K. You change the slide, it doesn't stick with that. Right, now the lab for next 2 weeks, right? So I give you 2 weeks to do this lab. Just find data set that you like, then perform 2 distribution analysis. One for categorical data, another for numerical data, and then explain the results in the following terms. First, the type of distribution, the values, the skewness, outliers, and modalities, okay? Values, type of distribution, the explain the results, the values of, it means that what values have what occurrence, if it's normal, if it's the continuous value, a numerical value, maybe the central measurements, just explain where do they located. Are there any skewness in the data set? Are there any outliers? How many modalities of the data that you have? You can use any data set that you like. Just find some in Kaggle and use just 2 variables from those data set. Don't forget, you need to summarize the data into the unit of analysis that you want to perform first. And then you can analyze distribution of those data according to the unit of analysis that you want. Okay, that's all for today's lecture and the lab. Any questions before we close these sessions? The due date would be 2 weeks from now because the next week is holiday. Just try to use holiday wisely though. You still have the track that you need to complete, and 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 then the tracks would due after the holidays, and lastly you also have this one to submit at that at that week as well. Now there's a question, where can you find the data set? You can find the data set from Kaggle. Did I show you that? I don't remember, but I suppose I have, right? Kaggle.com. You can get your data set from the Kaggle.com. Actually, in your project, you will need to select data set to do the project analysis project as well. And when you go to Kaggle, you can go to here, data, and then you can search for the data set that you like here. This is Netflix movies, COVID-19 vaccination progress. Yeah, lots of them. Just selecting one. Yeah, I'll put the link here. As in your project, if you remember in the first lecture, you need to perform data visualization and create models from the data. You need to select data set from here anyway, in that you work in groups. But for the assignments, you need to work individually. So just select one out of this and then pick two variables, two attributes that you like, and then analyze the distribution of those. And don't forget to interpret it as well. And then you can put everything into Words and export as PDF and submit to the LEB2. Okay. This is one of the source, but you can also use data from other sources like World Bank, Our World's data, and other sources as well. There are a lot of open source data. For Thai, there are data from Open Data. You just search Google from Open Data project from Thai government. I think it's data.gorth. I don't remember though. You just search Google and then try to find it out, the Open Data project, or you can use the data from whatever sources that you like. Just take data set that you like and then analyze to distribution, explain them, right? So that would be the job for your lab here. Okay. And any more questions? If not, then let's close the session. And if you have questions, post them into the group, okay? But try to post them as early as possible. Do not wait until the end and then do the job. It will not help you learning. Try to practice a lot. It will increase your skill in R, in data analytics, and that will be benefiting you in the long run. Okay, so let's close today's session and see you next time. Bye-bye.